Of all the forces at work in the realm of aviation technology, magnetics wouldn't necessarily be the first to come to mind. For many of us, the first thought connecting magnetics to aircraft technology would be that of the compass, as it interacts with the Earth's geomagnetic field to reveal the aircraft's current magnetic heading. A magnetic compass helps to confirm that an aircraft is traveling in the right direction. The most visible example it may very well be, yet magnetics play a crucial role in several key components and systems of an aircraft. And as evidenced by those produced by Arnold Magnetic Technologies, magnetics in aviation are far more than meets the eye.
No matter what aircraft you see in the air, no matter what aircraft you ride on, those aircrafts have our components on them.
Based in Rochester, New York, Arnold Magnetic Technologies are makers of electromagnetic components for motors and generator technologies. Not only can their products be found in virtually every aircraft in the sky, but as aircraft become more electrified, their electromagnetic components will be found throughout the power-producing systems in these same aircraft.
So when people think about where magnetics are in the aviation industry and in aircraft, they may think of things like a compass, because many people are very familiar with a compass and guidance on where I'm supposed to be going. But our magnetic technologies are used in electric motors and generators, which are found in a variety of systems across the entire aircraft. These are going to be in cabin air compressors, ram air turbines, integrated starter alternator generators, and the auxiliary power unit components of the aircraft overall. And why these permanent magnets are important is because permanent magnets enable more energy efficient electric motors and generators.
While the use of magnetics in compressors, turbines, and generators of an aircraft certainly suggest a change in how aircraft are built, more specifically and more importantly, it suggests a change in how these aircraft are being powered.
As we move away from traditional centralized hydraulic systems that move everything on the aircraft itself, we're moving toward localized electrification. As we move away from jet turbine compression engines, we're looking at how can we use electric motors, electric generators to make power and then use that power to propel the aircraft forward over the airfoils or the wings. So our components are going to be used in these electric motors. And the reason why people use our components is because they enable energy density.
Energy-dense systems support the notion of keeping the aircraft as light as possible without losing any of the power potential. With this energy-dense magnetic technology, many localized systems can be powered with electrical energy. To illustrate this, let's take the example of an aircraft's APU, or auxiliary power unit.
So what we have is we're using jet fuel to then go into a turbine to generate mechanical energy. That mechanical energy will then drive an electric generator. Inside that electric generator is where we're going to find Arnold components at this time. So taking a look at a much smaller system, we have permanent magnets that are on a rotor. This rotor system rotates, and those permanent magnets will then interact with the stator component of the generator. The stator component is a bunch of thin lamination material stacked together and then copper windings. And when those two systems interact, we're going to drive the generator. That generator is going to have that mechanical energy going in, and we'll get the electrical energy going out. And we're going to use that electrical energy to power really anything you can think of on an aircraft that needs power.
With the vast majority of electric vehicles on the road now being powered by an internal permanent magnet drive motor, the automotive industry offers a living example of how this technology can be successfully implemented. Yet a lot of work remains to be done before fully electrical aircraft will begin combing the skies of commercial aviation.
Putting that technology into commercial aviation definitely has a lot of hurdles to overcome. Passenger safety, aircraft safety, longevity of the operating systems, and efficiency of those operating systems. So there's definitely a lot of hurdles to overcome, but those are hurdles that engineering staffs at the airframers, at the tier 1s, at the tier 2s, we are putting our engineering teams together, working toward how to make these systems as power dense as possible, as efficient as possible, as safe as possible for the customer, and then reduce that dependence that we have on fossil fuels, much like you see from the automotive industry at this time.
With this push away from centralized hydraulic systems toward localized electrification, and away from jet turbine engines toward electric motors and generators, the means by which aircraft are powered is on the cusp of a large-scale transformation. As for the future, much like the movement toward electric cars, this more efficient means of aviation promises to leave a softer footprint on the skies and in turn on the world itself.
If we look at automotive manufacturers as we move from internal combustion to full-on electric vehicles, what can we do and how can we implement that inside commercial aircraft overall? Because that is the end goal, that is the target. So how are we going to generate the power? The power could be generated using a large generator powered by jet fuel at the rear of the airplane. We could use all that power to then power multiple electric motors on the airfoil, which would then be used to propel the aircraft. It seems very futuristic, very Jetsons, but this is really the way the industry is headed because we need to make our transportation systems, aviation included, more fuel efficient. So we reduce that dependency on fossil fuels that we have so much of right now.